Hello, welcome to a new problem in Thermodynamics Pure Substances, chapter 3 in the book Engineering Approach, edition 8. We have problem 342 here. As you can see, we have 100 kilos of refrigerant at 200 kilopascal, and it's contained in a piston cylinder device whose volume is 12.322 with an initial position. And then it is the piston is pushing the liquid down, so it becomes the half size, so the half volume in what you call it stage 2. The pressure does not change in that stage. Determine the final pressure and the change in the total internal energy. Skal vi look for? Okay, well, so we must have some information in this. In this initial position. So is this a saturated mixture? Is this saturated mixture in stage 1? Is it? Let's see, we have 12.2. Okay, let's see here. The VG is 0.099951 square meter per kilo. And then so we will see if this is so we have 100 kilos of this, so we will look at this 0.009995 times 100 kilo equals 9.9951 cube meter, which, and that you see that one, that is smaller than the total volume of 12.322. So it means, so it, even if it's gas, it does not cover the whole volume if it is saturated. But it means it's not saturated, because the gas do indeed cover the whole volume. So that must mean it's superheated refrigerant. It's superheated. So then we must go to the superheated table to find more. Okay, so that is table number. What table is it? Let me see. Superheated refrigerant, page 918. 918. There we go. It's saturated, and here is the superheated. Let's find if you can see the 200 kilopascal, and you can see here. And you see here. There, look at this. We can see this. This is exactly the volume we have. For example, if you multiply this with the 100 kilos, you will get 12.322. This is just like a random luck. Of course, they that made a problem, they know about this. But for real, if it's been a real problem, this is just random luck. But so we can use this. We will just bring this to the here. We'll bring this. We copy this just for order. So we are here. That one. So the T1, the temperature is 40 degrees Celsius. So, and then we have V1 is 0.12322, and then we have E1 is equal to, what is that? Yeah, 263.09 Koye per kilo, and that's all we need to know. That's all. We have everything in T1. That's what you have. What about T2? See here, no. After that, this piston is pushed down to half the size, which is 6.161. Then V2, the total volume, big V total volume, okay, 6.161 cube meter. That's the volume 2. We know the pressure is the same, 200 kPa. So what about this? How is this saturated this time? Because you can see that you can see that so we can see that yeah, you remember this here. Look at this. We look at this again. Look at this again. Here. We look at this. We have this again. As you can see, we have the total volume is now 6.161 cube meter, and if you count the gas only, if it's a pure gas, then it will be a volume of 9.9951 cubic meter, and that is bigger than the total maximum, and then the maximum possible volume. So that means it must be saturated. Then it's easy to see it's saturated. Stage 2 is saturated mixture. Which means that the temperature is 10.0, negative 10.09. We can write that up here for order. T2 is negative 10.09 degrees Celsius. I want a little bigger text. 14, let's say that, okay. And then what is next? We can write, we can just notify us this these things. Let's bring down the. Let's just copy this so we can easily see stuff. Let's have it here. Some VF equals 0.0007532 kilo per kilo, and VG is 0.09951 cube meter per kilo. Yeah, I don't remember where is that. I have to go up here again. And then we have the UF, UFG, and UG. Okay. UF equals 38.26 G per kilo, and UFG equals 186.25 per kilo. So there is some information we have from here. So we must find the internal energy. So which is E. We found that on stage 1. That was 260.9. Is that right? And U2. So what is U2? We have to, because it's saturated. You cannot just read there. You have to figure out the saturation quality and stuff. Look, you have this form, this equation here. To find the internal energy, you need to have UF. I will write in equation mode. It's also UF plus x x2 times UFG. That's what we need. So we have UFG and we have UF, but we do not have the mixture quality. Okay, so x to therefore the how to figure out that is mg gas, and then tot. That's our formula for that. And also x2 equals, what is it? Here we go. What is it? Vf divided on V2 minus Vf, and divided on VFG. There. VFG is the same as VG minus. Let's write this again then, maybe. Yeah, okay, just for structure. VG minus VF. That's it. Okay. Okay. Copy. Done. I think I'm getting becoming more efficient now, and I know how to get formulas again. They will be more efficient if I can remember to save the formulas next time. Let's see. V2. We found V2. I remember we did that. If I'm not wrong. Oh yeah, and okay. V2. We find V2. V2 equals, that's easy. That is just what was it? 6.161 meter, and then divide it on 100 kilo. She must be. Don't have. Then you find that. You see, and that is 0.06161 kilo. That's what it is. Okay. And then we will just put this in here. 0.06161. Huh? Oh yeah, I know that. VF 0.000 7532. 7532. And VG, we routed that. 0.099951. And the VF was 0.0007532. And then we use the calculator. 0.06161 negative 0.0007532 divide on 0.099951 negative 0.0007532, and then it will be 0.6135. That's the saturated. That's the mixture quality. Like 61.30. Just to show, for system. This is in percent. Of what it means. I'll just explain what it means. The mixture is vapor. That's what it means. All right. Okay, and then We will fill in for this. Let's see, let's go down here. UF 38.26, 38.26 plus 0.6135 times 186.25, and then the answer will be times 186.25 plus 38.26, 152.52 kilojoule per kilo. That's U2. And then we're not finished yet, because we need to find out oh, here we have to, this is our answer that we need to highlight that one. Okay, we will find it. The question was that we must find the change in total energy of the refrigerant. So that there delta U equals U2 minus U1 lik 152.52 on U2 up here. U1 I mean. U1 263.09, 263.09, and that will be like 110 or something. I want the exact number. 152 minus 2 is 3.09, negative 110.57 kilojoule per kilo. Yeah, it means that the internal energy have been reduced by 110.57 kilo per kilo. And so that is the answer on this. And that's all. Thank you for today, and see you again next time.